Hi friends, in this video we are going to see the modulation theorem. What this theorem says? If f omega is the Fourier transform of a function f, this is the given. Suppose I know what is the Fourier transform of f. That is Fourier transform of f equal to f of omega. They given. Then we have to find what is the Fourier transform of f of x times cos ax and Fourier transform of f of x times sin ax. We are going to see. So we start with first Fourier transform of f of x times cos ax. From the Euler formula, we can represent cos ax in terms of exponential of iax plus exponential of minus iax whole divided by 2. So, using this the Euler formula, f of x times exponential of iax plus exponential of minus iax divided by 2 I can write. Then we know that Fourier transform is the linear transformation. So, I can take 1 by 2 outside and Fourier transform of f of x times exponential of iax plus Fourier transform of f of x times exponential of minus iax I can represent. Okay. Then next is I will take this one is my I1, this one is I take I2. So I1 equal to Fourier transform of f of x times exponential of iax. Now, if you apply the definition, integral over minus infinity to plus infinite f of x times exponential of iax times exponential of minus I omega x dx. So, next step I will club the exponential function together. So, integral over minus infinity to plus infinite f of x times exponential of I take minus outside I times omega minus a times x dx I can write. So, what is the Fourier transform of f of x? Fourier transform of f of x equal to integral over minus infinity to plus infinite f of x times exponential of minus I omega x dx. This is equal to f of omega. So, instead of here omega, we have omega minus a. So, this implies I can represent f of, instead of omega, I write that f of omega minus a. Similarly, now I am going to find what is the I2. That is Fourier transform of f of x times exponential of minus iax. The same logic I applied, what I have done previously. That is integral over minus infinity to plus infinite f of x exponential of minus iax, the kernel of Fourier transform is exponential of minus I omega x times dx. If I add together, if I multiply these two guys together, exponential of minus I take omega plus a times x dx. The same way, f of omega is integral over minus infinity to plus infinite exponential of minus omega x dx. Instead of here omega, we have omega plus a. So, this is equal to f of omega plus a. So, this implies Fourier transform of f of x times cos ax equal to 1 by 2 common times I1. I1 is f of omega minus a plus f of omega plus a. This is the result for Fourier transform of this one. This 1 by 2 times f of omega plus a plus f of omega minus a. Now similarly, we are going to find the what is the Fourier transform of f of x times next is Fourier transform of f of x times sin ax. The same argument we are going to apply, integral over minus infinity to plus infinite f of x. Okay. Now, what is the sin ax? That is exponential of I ax minus exponential of minus I ax divided by 2I times exponential of minus I omega x. So, same way if you apply the same argument what we have done the previously, you will get 1 over 2I Fourier transform f of omega minus a minus f of omega plus c. So, this is equal to 1 over 2I times f of omega minus a minus f of omega plus c. So, otherwise you multiply the I numerator denominator, then it's become f of omega plus a. So, or you can write it in terms of I divided by 2 f of omega plus a minus f of omega minus c. These two way you can write. This result is known as modulation theorem. I hope you understand how to derive the modulation theorem. Thank you for watching this video.